Hello everybody, welcome back to Calculus. Today we are starting a whole new section. We are starting the section on derivatives of trig functions, which are surprisingly easy compared to some other derivatives that we will have to take before we go forward. Enjoy this meme that I found when I googled derivatives of trig functions. It's both hilarious and true. So, we need to know how to take the derivatives of trig functions for several reasons. One, because why wouldn't we? But two, trig functions show up a lot in natural phenomena. So when we start looking at word problems and stuff, we see a lot of trig functions with wave motion and stuff like that. So it's pretty important that we are able to take derivatives of trig functions. I want you to look at these two graphs very, very carefully. Hopefully they are familiar graphs to you. This blue one here is our friend sine, and the red dotted line is our friend cosine. And you may or may not recognize this guy, but this is Brown Bear down here. And Brown Bear says, what do you see? I see derivatives looking at me. Facts. I want you to check out these two graphs and tell me what you think about the derivative of the sine and the derivative of the cosine. Look at how these two graphs are compared to each other, and remember what a derivative is. A derivative is the slope of a function. Can you tell from these graphs what the derivative of sine and the derivative of cosine might be? Okay, so notice here, every time your sine function has a zero slope, every time it has a horizontal tangent, look what your cosine function is doing. Zero slope, horizontal tangent, the cosine's at zero. Look at this beautiful lining up. Every time sine has a horizontal tangent, cosine is at zero. So, The other thing we notice here is that whenever sine has positive tangent lines, so in this region, all the way from here to here, and then again from here to the end, notice what cosine's doing. In this whole interval, cosine is above the x-axis. Again, in this whole entire interval where sine is increasing, cosine is above the x-axis. The only time cosine dips below the x-axis is when you see your sine function decrease or have negative tangent line slopes. Guess what? The derivative of sine is very simply cosine. Period. All we have to do is memorize that. Now, does it work the other way around? If you look at the zeros, the zero slopes of cosine, here, 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 they do indeed line up with the y values of zero on sine. So we may think, oh, it's the same. But there's a little problem. Notice that when cosine has negative tangents or negative slopes, look what sine is doing. Positive. Then cosine decides it's going to have positive slopes, and sine says, I'm going to go ahead and be negative. So it has the right zeros, but the signs are all wrong. And so as a result, the derivative of cosine isn't sine, but negative sine. Now listen, if you know those two, you can get the derivatives of anything trig, because as you remember, I'm sure fondly, from L-Fun, or pre-calc as you now call it, you can take any expression in trig and rewrite it in terms of sine and cosine. You may not like doing it, but you can. So even if these are the only two trig derivatives that you ever knew, you'd still be able to take the derivatives of all the trigs. Pretty cool. All right, so what we're going to do, now that we know the derivatives of trig functions, is start taking some derivatives that involve trig functions. So maybe they'll ask us just what's the derivative of sine, but probably not. What we see is them showing up in more complicated functions. So for example, here I have a product where one of the pieces or one of the factors happens to be a sine. Well, that's okay. We know how to do the product rule. So when I do my product rule, I have first derivative of second. The derivative of sine is cosine. There's nothing to do. We just have to know. We just have to memorize it. So first, derivative of second, so the derivative of sine is cosine, plus sine times the derivative of x squared, which is 2x. So what we get here it's worth noting once again that this is an equation for slope. This is an equation for the slope of this graph, which is actually amazing to me. And again, I want you to notice something. Look at this. Just for a quick example, when x is 0, both of these go to 0, and you have a 0 slope. Look at your graph. When x is 0, there's a horizontal tangent in there. So again, there's going to be lots of places where this has a value of 0, and you can see this function has lots of peaks and valleys, and this is just a little bit of this function. But all we have to do is memorize derivatives of sine and cosine, and we can pop them in and use them now in product rule, in the quotient rule, in any rule we want. Anytime they pop up, we're able to use it. Okay, here's an example of one where we see it in a quotient rule, and we see both numerator and denominator. So again, I'm going to just treat this like any other quotient, and I'm just going to follow the quotient rule. So if I want f prime of x, I need to start with my denominator. And I need to end with my denominator. So denominator, derivative of the numerator. So the derivative of cosine, we memorize. It's just sine. I'm sorry, negative sine. Minus cosine times the derivative of 1 minus sine x. So the derivative of 1 is 0 minus the derivative of sine, which is cosine. Okay, so you may leave that there. Again, if it's open-ended, do it. If this is multiple choice though, I promise you this is not what you're going to see. And here's why. This numerator simplifies drastically. If you distribute this sine x, you get negative sine x plus sine squared of x plus cosine squared of x. And you may remember, and this is really the only trig identity that AP ever brings up and expects anything from us on, that sine squared plus cosine squared is an identity, and we know for a fact that it equals 1. So look at this function and how it simplifies. I now have a 1 minus sine x in the numerator, and I have a 1 minus sine x squared in the denominator. So you can cancel your numerator with one of those, and that hot mess simplifies all the way down to 1 over 1 minus sine x. Again, it's important to know that if you're doing a multiple choice, you might have to do some simplification. So if the answers look way simpler than what you've got, especially when there's sines and cosines involved, you may want to watch out for that identity. Again, the AP really doesn't expect us to use all the trig identities, but they do expect us to know sine squared plus cosine squared equals 1. So, okay, and again, if you look at this, this is a formula for slope. Right? I can't find my pen. Whoops, sorry. This is a formula for slope. So look, every time sine x is equal to 1, I'm going to have undefined slope. And you see this? You have all these undefined slopes. Spots with undefined slopes. Pretty neat. Okay. So, as I said before, as long as you know the derivative of sine and cosine, you can find the derivative of any trig function. So for example, tangent, I can rewrite in terms of sine and cosine, right? I know that the tangent is just the sine x over cosine x. And so if I want to know the derivative of tangent, all I have to do is rewrite it as sine over cosine, and I can use the quotient rule. So I have a numerator and I have a denominator. So to take my derivative, I'm going to start with my denominator, and I'm going to end with my denominator. So denominator, derivative, numerator. The derivative of sine is cosine. I see a cosine squared. Minus numerator, sine x. Derivative of denominator, the derivative of cosine is negative sine x. And check out what I have. In my numerator, I have a cosine squared x plus a sine squared x. In my denominator, I have a cosine squared of x. So this ends up being 1 over cosine squared of x. And you might say, wait a minute, I know a fact. 1 over cosine is its own trig function. That's secant. So guess what? I can rewrite this as secant squared x. Do I have to? No. But guess what? Now that I know what the derivative of tangent is, I'm never doing what we just did again. Because I now know that the derivative of tangent is secant squared. So if that comes up for me, I don't need to do this again. It's just another one I can put in the bank. I know that the derivative of sine is cosine, the derivative of cosine is negative sine. Now I know that the derivative of tangent is secant. Secant squared. Woo, woo. Speaking of secant, let's find its derivative. So, secant is 1 over cosine. So, I kind of need a quotient rule here, right? So, I have denominator to start and denominator to finish. So, denominator, derivative of numerator in this case is just 0, minus my numerator, the derivative of my denominator, again the derivative of cosine, negative sine. So negative sine x. Now, I'm going to simplify this a bit, and here's why. Notice this question didn't ask for the derivative, it asked for the second derivative. Right? So this is the first derivative. I need the second derivative. So I have a couple options here for what we want to do algebraically. I could rewrite this as the sine of x over cosine x times cosine x. I would have a quotient rule that has a product in the basement. I could also say, okay, well, this is a tangent, and then this is a secant, and use a product rule. Now, we just learned what the derivative of tangent is. Derivative of tangent is secant squared. And we also just figured out what the derivative of secant is. It's sitting right there. Okay. In other words, the derivative of secant, this simplifies to secant x tangent x. So if I have sine x over cosine x squared, which is what this came out to, you can break it up. When you break it up, you get a tangent x and you get a secant x. So now I know the derivative of secant. Okay. So if I want to take the second derivative of this, again, I can use a quotient rule with a product in the basement, or I can come over here and do a product rule. Frankly, I prefer a product rule. So for my second derivative, I have my first term, tangent, times the derivative of my second. So we know, we just found it, that the derivative of secant is secant x tangent x plus the derivative of secant secant times the derivative of tangent, which we now know is secant squared of x. There's my second derivative. It's a secant x times a tangent squared x and a secant cubed of x. Fancy. Now, you do not want to take a third derivative here. If you take a third derivative, you have three terms here, so you have a product rule and a product rule, and you have three terms here, so you have another product rule inside of a product rule. Let's not take the third derivative. Okay. So, look here. We know sine, the derivative of sine is cosine. We know the derivative of cosine is negative sine. We know that the derivative of tangent is secant squared of x, and we figured out that the derivative of secant is the secant x times the tangent x. Secant's my favorite one because it shows up in its own derivative. Fun. All right, so remembering what we knew from before, that f prime of sine x is cosine x, but that f prime of cosine x is the negative sine x. I want to point something out to you about derivatives. All of your co-functions are exactly the same as their counterparts with one exception. They are negative. Okay. They're negative and they're co. Right? So, for example, the derivative of secant is secant tangent. The derivative of cosecant is going to be negative. Instead of secant, it's cosecant, and instead of tangent, it's cotangent. So the derivative of cosecant is negative cosecant cotangent. Again, notice the similarity from here to here. The co-function is always negative derivative, and it's the same as secant, but they are the co-functions. So instead of a secant, we have a cosecant. Instead of a tangent, we have a cotangent. So down here for cotangent, it's going to be just like the derivative of tangent with those couple changes. Since it's a co-function, I know the derivative is going to be negative. And over here it's a secant squared, so over here it's going to be a cosecant squared. Okay, now we could go do these derivatives just like we did these ones. I could rewrite cotangent as cosine over sine and do a quotient rule. I could write this as 1 over sine and do a quotient rule and do a rewrite. This is what we're going to get. Okay, so you don't need to do that. If you want to, have at it, but you don't need to. All you need to do is memorize, get them in here, those 6 facts. Derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of secant is secant tangent. The derivative of cosecant is negative cosecant, negative cosecant cotangent. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. Get them in your brain. Also get them on your rules of differentiation sheets. But more importantly, get them in your brain. Okay? This isn't a way we're going to lose a point. This is memorization. I don't need to do, there's no calculus to be done other than to have the derivative of this function memorized. Okay? So tomorrow we shall practice with trig derivatives. I'm looking forward to it. See you soon.